This is episode 10, 2026. My name's Clemens. We're talking about AMQP, and this is Subscribe. Welcome back. Today we talk about AMQP. AMQP is the Advanced Message Queuing Protocol, and it's a foundational protocol for most of the messaging brokers you use today, either on premises or in the cloud. Certainly very many of the most modern message brokers, including the broker that we build, Azure Service Bus, and also for our Azure Event Hubs. AMQP was not originally created by technology companies, but was actually created by what we could call a customer company, by John O'Hara at JP Morgan. Had the problem that they were in a bad negotiation situation, so to speak, with their messaging vendor, because they were locked in. Back in the day, in the early 2000s, if you were in a financial industry, you were dependent on queues. And you really only had a choice between a few vendors, and each of those vendors had a proprietary protocol and also proprietary APIs. And if you were trying to build applications, those would inevitably be locked into that one product. So they wanted to change that, and so they got a lot of Wall Street firms involved. Eventually, also technology firms involved. Microsoft eventually joined that effort to build AMQP. Initially, they got folks like Peter Hintjens from iMatix involved to kind of build the first foundations of it, and then more and more people signed up. So it became a very broad effort to build a common protocol. I myself, I'm the co-chair of the AMQP Technical Committee. We're mostly stewards of the standards. We're doing some additions, and we're about to revive that committee. But I was not amongst the folks who initially have developed that protocol. But I've been, creating a course. It's pretty popular on YouTube, and I'm also going to point you in the show notes to that course. So this is a super short version of it, so that you understand what AMQP is. There's also some misunderstandings, I would say, about AMQP, because AMQP had a tumultuous initial time during development. Initially, it was a protocol was very tightly coupled to a particular notion of a topology of what a broker would look like. And if you look at, for instance, RabbitMQ, RabbitMQ has echoes kind of the original AMQP version in the form of what's called exchanges and the queues that are hanging off it. And those were very strongly reflected in the AMQP 0.9 protocol, up to 0.9. Then there was a kind of a spat in the community when we went from 0.9 to 1.0, which ended up being a very different protocol. And the reason for splitting this was that we wanted to make, and this was something where I was already involved in Microsoft, kind of in the back office, if you will. We wanted to make sure that the topology is not baked into the protocol per se, that there's no fixed notion of queues and no fixed notion of topics inside of that protocol, which paid off because we now use AMQP for literally trillions of transactions per month very successfully in Event Hubs, and Event Hubs is not a queue broker. So that worked. So and I'm going to spend the rest of this episode talking about AMQP and the elements of it, so you understand what kind of a protocol that is. So it's a standard. It's an international standard. It's an ISO IEC standard. So we finished this in 2012. From Microsoft side was David Ingham was our representative in that group. So then we finished that work, and then this progresses through the mechanics of standardization into ISO and IEC, and then became a formal ISO IEC standard in 2014. So it's capital S standard. What it is, it's a layer transport. There's a transport layer, transport and connection security protocol. There's a frame transfer protocol. There's a message transfer protocol, all of which I'm going to explain to you in this short session. So quick overview over those layers. The frame transfer protocol is the underlying, how do I format the socket? So you have a notion of two containers. Then those two containers establish a connection. We're going to get to how that works. Once you have a connection established, then you need to format that connection. You need to go and turn sequence of bytes in both directions into segments that you can then go and manage. There's a frame size, and there's also some level of multiplexing that you already can go and do that level. But frame size, for instance, is a negotiated thing. The server will tell you, I'm willing to take messages or frames up to, let's say, 1 megabyte in size, and the client understands that through the negotiation. It will then do that. So this is the underlying, so containers and sessions is the foundation that kind of formats the wire, if you will. Then there is a message transfer protocol that sits on top of this. So we have a negotiation of getting to these sessions, getting to these links, these transfer links. And the message transfer protocol and the session, the underlying protocol, these two layers are such that the message transfer protocols, those so-called links through which you can transfer those things, can actually survive the dropout of the connection underneath. So you can go and establish a new session, a new connection, a new session of it, and then you can go and revive these links. So this layer on top, this link layer, is something that is actually reconnectable. You can go and recover those sessions, and it's independent effectively of the individual socket. A link is something you establish either in a sending direction or in the receiving direction. So it's a unidirectional transfer path. You can, between two containers, a client and a server. AMQP does no direction. So you choose the roles that you want. So a container, client, and a server, they can go and create these links in either direction. And what happens on the other direction of a link, you do transfers in one direction and you do settlement, which means you say, this is what's going to happen to that. This is what happened to this message on my end to the other side. And the other side then goes and reacts to it. We're going to go into more detail in a second. The connections are, that's the lowest level, is being established over a socket stream transport. So you can go and use TLS, so TCP with TLS on top, or you can go and use TCP with TLS on top, with HTTP on top, with WebSockets on top, and then layer AMQP on top of it. AMQP also has a way to, AMQP has its native TCP protocol, so you can start with an AMQP unsecured socket, and then you can do a TLS handshake inside of it, but that's something that is very rarely done. Typically, AMQP is used with a TLS socket that you start with, and then you overlay AMQP of it. But it's a layered system that you can go and put things on top. You can also layer AMQP on every other stream transport. So if you wanted to go and put AMQP over QUIC, you can certainly do that. It's just not something that is standardized in any way. What is standardized is the authorization authentication story, authentication story here. Specifically, AMQP is leveraging the SASL framework. So it's using the mechanisms that are defined in SASL. There's SASL plain to do password authentication. There's a way to tie in certificate authentication, and there's also a way to do OAuth. So it's leveraging those capabilities, and then the brokers that are implementing this implement one or the other SASL mechanism. And these are all built into the libraries that you'll deal with. Drilling down a little bit more on kind of how these exchanges work, there's only a few so-called performatives. These are the messages that are basically exchanged. So once you have a connection, you go and send begin to go and create a session, and that's why your negotiation starts. AMQP has two principles. First of all, it wants to be super compact on the wire, so it it exchanges identifiers that both parties can go and deal with, but then switches them usually to an integer value. So it's shortening the wire footprint for all future exchanges. And it has always a notion of offering capabilities and then accepting those capabilities, basically going through a negotiation phase. So what you negotiate on the session level is you negotiate, for instance, the frame size. And frame size being what is the maximum transfer unit that I will allow. That's not necessarily the maximum message size, because you can go and split a transfer across many, many, many different frames, but it's the biggest frame that you can transfer at once. Sessions, this lowest layer that exists, this gets reestablished whenever you reconnect, also has a flow control model, which we're going to get to on a future slide. And links also have a flow control model, but I'm going to cover that in the summary slide in a moment. Then once you have a session, you can go and establish 1, 2, 3, however many links you want. And a link is a named transfer route that goes from a source. You create a client, and that client is you create the link in a role. So you are either a sender or a receiver. And then there's a source, that's where the messages originate from, and a target where the messages go from. So if you are in the receiver role, your source is where you get the data where the data comes from. If you're in the sender role, the source is where that goes to, and then you define the target. You can, because AMQP is not directional, any of these parties can go and set up one of those routes. So you can be a client, and you can go and define a receiver into a thing, and then it will go get messages if it's willing to give those to you, the opposing node inside of the container. Or you can go and create a sender. And even a server can go and create a receiver onto a client that usually won't be answered, but the protocol is flexible enough. It's really built for the classic client sender role, but also for peer-to-peer communication, and it's very, very well suited for that. The way how it exchanges, so you attach to another party. As you attach, you can go and provide so-called link properties, and the link properties will, and configuration settings that are also sometimes in the source and the target, and you can go and configure what is your relationship to the other party. One of the things that we have formalized, for instance, in the GMS extensions to AMQP, just using the extensibility mechanisms that are there, is that we can say the target is a durable, so-called durable terminus, and it has a particular set of capabilities so that you can go and create a temporary queue simply by attaching to it inside the broker. And all the brokers that are following that same spec, that be Apache Cupid and Apache ActiveMQ and also Service Bus, will go and behave exactly the same way, and they will spontaneously go and create a temporary queue if you talk to them in the right way. And of course, you're going to attach to existing queues. And similarly, you can also go and attach to a topic inside of your topology, and it will spontaneously then go and create a temporary subscription or a durable subscription, depending on how you do this. And this is all, we didn't have to go and modify the core AMQP spec for this. We only are using effectively the extensibility mechanisms that live in this side of this link mechanism. AMQP has its own type system, very comparable to Protobuf or Avro. It's super compact. It's as compact basically as Avro or Protobuf, with a lot of tricks for making sure that numbers are super efficiently encoded. The only the limitation that exists, and this is why you don't see widespread use of the AMQP type systems outside of the core stack, is that very few stacks have actually made their serialization library, their AMQP type library, externally usable outside of the core messaging stack. But it's as efficient of a encoding as most of the other popular binary encoding models. It has schema bound modes, so that you need to know the schema to understand a sequence of values, or it has a schema free mode, just like JSON or message pack, where you are sending basic key value pairs around. And mixes of those are used in the AMQP message model. And you can completely just stick with the AMQP message model even for business application messages that you send, and it's actually built for that. AMQP messages are expressed in that type system, and the reason why we have that sort of the type system here is that, of course, AMQP tries to be completely neutral to programming languages and work across any number of programming languages. So we can't double down on a single language that, as for instance JMS does. So we need to have some neutral ground, and that's kind of what we use that. The AMQP message is expressed in this, and it has a bare message part, a body, application properties, and so-called properties. The properties are a predefined set of very commonly used messaging constructs: a reply to, a to, a subject, an expiry time, etc. Application properties is a free-form metadata property bag, and then the message body is where you would put your payload. And then there's a greater set of annotations, and that's called the annotated message. The bare message, when once constructed, must not be changed by any of the parties that are dealing with AMQP messages. But the annotated message, that can actually be modified, and there can be annotations added as the message is being transferred and handled. So when we go and give you, for instance, in Service Bus information about how we have handled the message, if we give that to a receiver, or if we do that inside of event hubs, when we tell you, this landed at this offset, that's all landing in the message annotations. AMQP has its own addressing system. So there's an AMQP URI model that most of the brokers understand. The scope piece is part of the newest revision of the AMQP addressing spec, and that's not widely supported, but basically when you go and take a network endpoint and you attach the path to it, that is the model that usually most brokers understand. When I send a message, I now have a link, I have an AMQP message, now I want to go and send it. There's multiple modes. There's a fire and forget mode at most ones, where you can go and transfer the message. So you go and create a transfer performative, a wrapper. You stick the message into it, and then you send that over your link. If you send settled true, then the receiver doesn't need to do anything. Its transfer has happened. It's fire and forget. If you have, and you can do this with Service Bus too, if you go and drop down to the bottom and simply don't use our SDK. Our SDK by default sends settled false, which means you transfer and then you wait for the server, or the client waits for the server, or the server waits for the client. This is symmetric, to send a disposition frame. The disposition frame then basically says, this is what the other side, the sender, ought to do with that message. And there's multiple modes. There's accept, seen from the perspective of the receiver, which means I'm happy with that message, I dealt with it, you can go and delete it. Reject means I don't know what to do with this, and you better put it away. That is effectively causing an exception on the client, or it's causing the message to be dead lettered in the broker. You can say release, which means I can't deal with that right now, but you can go and try redelivering it. That's how you go put messages back into the queue. So there's a state machine that's kind of implied here, which basically tells the other party what to do with that message. And when that gets interrupted, you can go and then send the message. And if you get interrupted during that handshake and the connection drops out, and you have a server that is supporting the recovery mode, then you can go and, after the links have been renegotiated, kind of this state that the message is known to be in is part of that negotiation, then you can go and still settle the message even though the connection dropped out from under the bottom. There's two flow control modes, alluded to that in the beginning. There's a session flow control that is effectively allowing the broker or the other party to just summarily start blocking kind of further flows if it can't deal with any traffic anymore, or if it needs to go and throttle the total amount of bandwidth towards it. And link flow control is kind of on a per link basis. You can have hundreds, thousands of links that sit on a single connection. And so when you need to go and put back pressure on an individual queue, or if the queue is starting to be full, or if you are having trouble getting data serialized back to disk, then you can go and basically reset your link flow control. You can take away, as it's called, credits. And that's what I already had. That's already what I had in AMQP. Took a little bit longer than 10 minutes usually. It's a very complicated protocol. There is a course where I explain that in more detail. I look much younger in that course, and I also don't have a beard. But if you're interested in more details on AMQP, including details on the type system, then you can go and watch that course. In the next episode here, we're going to talk about MQTT.